Chapter 32 of Astronomy, The Science of the Heavenly Bodies, by David Todd. The Ruddy Planet. Mars is a planet next in order beyond the Earth, and its distance from the Sun averages 141.5 million miles. It has a relatively rapid motion among the stars. Its color is reddish, and when nearest to us, it is perhaps the most conspicuous object in the sky. Mars appeared to the ancients just as it does to us today. Aristotle recorded an observation of Mars 356 BC when the moon passed over the planet, or occulted it, as our expression is. Galileo made the first observations of Mars with a telescope in 1610, and his little instrument was powerful enough to enable him to discover that the planet had phases, though it did not pass through all the phases that Mercury and Venus do. This was obvious from the fact that Mars is always at a greater distance from the Sun than we are, and the phase can only be gibbous, or about like the Moon, when midway between full and quarter. Many observers in the 17th century followed up the planet with such feeble optical power as the telescopes of that epoch provided. Fontana, who made the first sketch, Riccioli and Bianchini in Italy, Cassini in France, Huygens in Holland, and later Sir William Herschel in England. It was Cassini who first made out the whitish spots, or polar caps, of Mars in 1666, but not until after Huygens had noted the fact that Mars turned around on an axis in a period but little longer than the Earth's. Cassini followed it up later with a more accurate value, and observations in our own day, when combined with these early ones, enable us to say that the Martian day is equal to 24 hours, 37 minutes, 22.67 seconds, accurate probably to the 100th part of a second. When we know that a planet turns around on an axis, we know that it has a day. When we know the direction of the axis in space, or in relation to the plane of its path round the Sun, we know that it has seasons. We can tell their length and when they begin and end. It did not take many years of observation to prove that the axis round which Mars turns is tilted to the plane of its path round the Sun by an angle practically the same as that at which the Earth's axis is tilted. So, there is the immediate inference that on Mars, the order and perhaps the character of the seasons is much the same as here on the Earth. At least two things, however, tend to modify them. First, the year of Mars is not 365 days like ours, but 687 days. Each of the 4 seasons on Mars, therefore, is proportionally longer than our seasons are. Then comes the question of atmosphere. How much of an atmosphere does Mars really possess in proportion to ours? And how would its lesser amount modify the blending of the seasons into one another? All discussion of Mars and the problems of existence of life upon that planet hinge upon the character and extent of Martian atmosphere. The planet seems never to be covered, as the Earth usually is, with extensive areas of cloud, which, to an observer in space, would completely mask its oceans and continents. Nearly all the time, Mars, in his equatorial and temperate zones, is quite clear of clouds. A few whitish spots are occasionally seen to change their form and position in both northern and southern latitudes, and they vary with the progress of the day on Mars, as clouds naturally would. But Schiaparelli, perhaps the best of all observers, thought them to be not low-lying clouds of the nimbus type that would produce rains, but rather a veil of fog, or perhaps a temporary condensation of vapor, as dew or hoarfrost. But the strongest argument for an atmosphere is based on the temporary darkening or obscuration of well-known and permanent markings on the surface of Mars. These are more or less frequently observed, and clouds afford the best explanation of their occurrence. So much for evidence supplied by the telescope alone. When, however, we employ the spectroscope in conjunction with the telescope, another sort of evidence is at hand. Several astronomers have reached the conclusion that watery vapor exists in the atmosphere of Mars, while other astronomers, equipped with equal or superior apparatus and under equally favorable or even better conditions, have reached the remarkable conclusion that the spectra of Mars and the Moon are identical in every particular. From this, we should be led to infer that Mars has perhaps no more atmosphere than the Moon has, that is to say, none whatever that present instruments and methods of investigation have enabled us to detect. What, then, shall we conclude? Simply that the atmosphere of Mars is neither very dense nor extensive. Probably its lower strata close to the planet's surface are about as dense as the Earth's atmosphere is at the summits of our highest mountains. This conclusion is not unwelcome if we keep a few fundamental facts in clear and constant view. Mars is a planet of intermediate size between the Earth and the Moon. Twice the Moon's diameter, 2,160 miles, very nearly equals the diameter of Mars, 4,200 miles, and twice the diameter of Mars does not greatly exceed the Earth's diameter, 7,920 miles. As to the weights or masses of these bodies, Mars is about 1/9, and the Moon 1/80th of the Earth. The atmospheric envelope of the Earth is abundant. The Moon has none, as far as we can ascertain. So, it seems safe to infer that Mars has an atmosphere of slight density, not dense enough to be detected by spectroscopic methods, but yet dense enough to enable us to explain the varying telescopic phenomena of the planet's disk, which we should not know how to account for if there were no atmosphere whatever. One astronomer has indeed gone so far as to calculate that in comparison with our planet, Mars is entitled to 1/20th as much atmosphere as we have, and that the mercurial barometer at sea level would run about 5.5 inches, as against 30 inches on the Earth. In general, then, the climate of Mars is probably very much like that of a clear season on a very high terrestrial tableland or mountain, a climate of wide extremes, with great changes of temperature from day to night. The inequality of Martian seasons is such that in his northern hemisphere, the winter lasts 381 days, and the summer only 306 days. Now, the polar caps of Mars, which are reasonably assumed to be due to snow or hoarfrost, attain their maximum 3 or 4 months after the winter solstice, and their minimum about the same length of time after the summer solstice. This lagging should be interpreted as an argument for a Martian atmosphere with heat-storing qualities, similar to that possessed by the Earth. Upon this characteristic indeed depends the climate at the surface of Mars, whether it is at all similar to our own, and whether fluid water is a possibility on Mars or not. While the cosmic relations of the planet in its orbit are quite the same as ours, nevertheless, the greater distance of Mars diminishes his supply of direct solar heat to about half what we receive. On the other hand, his distance from the Sun during his year of motion around it varies much more widely than ours, so that he receives, when nearest the Sun, about 1/2 more of solar heat than he does when farthest away. Southern summers on Mars, therefore, must be much hotter, and southern winters colder than the corresponding seasons of his northern hemisphere. Indeed, the length of the southern summer, nearly twice that of the terrestrial season, sometimes amply suffices to melt all the polar ice and snow, as in October 1894, when the southern polar cap of Mars dwindled rapidly and finally vanished completely. Very interesting in this connection are the researches of Stoney on the general conditions affecting planetary atmospheres and their composition. According to the kinetic theory, if the molecules of gases which are continually in motion travel outward from the center of a planet, as they frequently must, and with velocities surpassing the limit that a planet's gravity is capable of controlling, these molecules will effect a permanent escape from the planet and travel through space in orbits of their own. So the Moon is wholly without atmosphere, because the moon's gravity is not powerful enough to retain the molecules of its component gases. So also, the Earth's atmosphere contains no helium or free hydrogen. So too, Mars is possessed of insufficient force of gravity to retain water vapor, and the Martian atmosphere may therefore consist mainly of nitrogen, argon, and carbon dioxide. As everyone knows, the axis of the Earth, if extended to the northern heavens, would pass very near the North Polar Star, which on that account is known as Polaris. In a similar manner, the axis of Mars pierces the northern heavens about midway between the two bright stars Alpha Cephei and Alpha Cygni, Deneb. The direction of this axis is pretty accurately known because the measurement of the polar caps of the planet as they turn round from night to night, year in and year out, has enabled astronomers to assign the inclination of the axis with great precision. These caps are a brilliant white, and they are generally supposed to be snow and ice. They wax and wane alternately with the seasons on Mars, being largest at the end of the Martian winter and smallest near the end of summer. The existence of the polar caps, together with their seasonal fluctuations, afford a most convincing argument for the reality of a Martian atmosphere, sufficiently dense to be capable of diffusing and transporting vapor. The northern cap is centered on the pole almost with geometric exactness and as far as the 85th parallel of latitude. On the other hand, the south polar cap is centered about 200 miles from the true pole, and this distance has been observed to vary from one season to another. No suggestion has been made to account for this singular variation. On one occasion, it stretched down to Martian latitude 70 degrees and was over 1,200 miles in diameter. Pickering watched the changing conditions of shrinking of the south polar cap in 1892 with a large telescope located in the Andes of Peru. Mars was faithfully followed on every night but one, from July 13 to September 9, and the apparent alterations in this cap were very marked, even from night to night. As the snows began to decrease, a long, dark line made its appearance near the middle of the cap and gradually grew until it cut the cap in two. This white polar area, and probably also the northern one in similar fashion, becomes notched on the edge with the progress of its summer season. Dark interior spots and fissures form. Isolated patches separate from the principal mass and later seem to dissolve and disappear. Possibly, if one were located on Mars and viewing our Earth with a big telescope, the seasonal variation of our north and south polar caps might present somewhat similar phenomena. all the recent oppositions of Mars have been critically observed by Pickering from an excellent station in Jamaica. Quite obviously, the fluctuations of the polar caps are the key to the physiographic situation on Mars, and they are made the subject of the closest scrutiny at every recurring opposition of the planet. Several observers, Lowell in particular, record a bluish line, or a sort of retreating polar sea, following up the diminishing polar cap as it shrinks with the advance of summer. It is said that no such line is visible during the formation of the polar cap with the approach of winter. All such results of critical observation, just on the limit of visibility, have to be repeated over and over again before they become part of the body of accepted scientific fact. And in many instances, the only sure way is to fall back on the photographic record, which all astronomers, whether prejudiced or not, may have the opportunity to examine and draw their individual conclusions. Already, the approaching opposition of 1924, the most favorable since the invention of the telescope, is beginning to attract attention, and preparations are in progress of new and more powerful instruments with new and more sensitive photographic processes, by means of which many of the present riddles of Mars may be solved. End of chapter 32.